today here we are going to understand the concept of boundary layer theory. Okay, so for that let us consider a solid boundary which is at rest. And let us consider a real fluid which is flowing with free stream velocity capital U. And it is a real fluid. Okay, real fluid means a fluid which will have viscosity as well as it is compressible. So here we are considering a solid boundary which is at rest, and we are considering a real fluid which is viscous fluid and compressible, flowing with a free stream velocity capital U. Now when this real fluid comes in contact with this solid boundary, the fluid particles will adhere to this solid boundary and condition of no slip occurs. Okay, and after that, as the fluid is continue to flow, the fluid particles will move in the forward direction, resulting in the increasing velocity in the flow direction, and as a result of which the velocity gradient du by dy exists. Now we have discussed this du by dy, Newton's law of viscosity, where u is the rate of change of velocity in x direction and y is the rate of change of distance in y direction. So let's say small u will be the velocity of fluid after coming in contact with this solid boundary. Now as it will continue to, as the velocity will continue to change and as the du by dy exists, there will be a narrow region up to which this du by dy exists, and after some point this small velocity will become 0.99 times capital U. इसका मतलब क्या है कि जो वेलोसिटी फ्लूइड की है आफ्टर कमिंग इन कॉन्टेक्ट विथ सॉलिड बाउंड्री, वो एक हद तक चेंज होगी, एंड आफ्टर सम टाइम, आफ्टर एट सम डिस्टेंस फ्रॉम दिस सॉलिड बाउंड्री, वो जो वेलोसिटी में चेंज है वो इक्वल टू 0.99 टाइम्स इक्वल हो जाएगा किससे, जो हमारी बाउंड्री से पहले, बाउंड्री से कांटेक्ट में आने से पहले जो फ्लूइड की वेलोसिटी थी उससे. So here at this point small u will be 0.99 times capital U, which means that the velocity of the fluid after coming in contact with the solid boundary will become almost equal, 0.99 times equal to the free stream velocity that was the velocity of fluid before coming in contact with the solid boundary. So because of this solid boundary ये region में velocity change होगी, and that because of change in that velocity this du by dy exists. So the narrow region where the velocity will variate from 0 to 0.99 times capital U is referred to as solid boundary. ओके, सो ये रीजन में क्या हो रहा है, ये रीजन में डी यू बाई डी वाई एग्जिस्ट कर रहा है बिकॉज हमारी वेलोसिटी चेंज हो रही है एज इट इज़ इन कमिंग इन द कॉन्टैक्ट विद द सॉलिड बाउंड्री, एंड हेंस द थियोरी विच इज़ रिलेटेड विद दिस सॉलिड बाउंड्री लेयर is referred to as boundary layer theory. So boundary layer can be defined as a narrow region where fluid velocity increases from 0 on the stationary boundary to free stream velocity. Okay, so boundary layer is defined as a narrow region where your fluid velocity increases from 0 near the boundary to free stream velocity at a distance y from the boundary. And here we can, after defining this solid boundary layer, we can divide this region into two portions, number 1 and number 2. So in this region du by dy exists, while in this region du by dy doesn't exist. Why it doesn't exist? Because now in this region the velocity is not changing and it has become almost equal to the free stream velocity, which was the velocity of fluid before coming in contact of the solid boundary. So small u is 0.99 times capital U. So here small u is the velocity of fluid after coming in contact with the solid boundary, while capital U is the velocity of fluid before coming in contact with the solid boundary. And this equation is of utmost importance in your competitive exams also. Okay, so here in this region as du by dy exists, shear stress exists. And as we have discussed in Newton's law of viscosity, tau is equals to mu du by dy. So here shear stress exists in this vicinity as du by dy is existing, while in this region as du by dy does not exist, shear stress will be 0. Hence Newton's law of viscosity will be not applicable in this region. Okay, thank you.